Hi everyone, this is the gas walkthrough for August 12th. I'm Philip Newman. Today's puzzle is The Most Gorgeous Day in History by Bill Murphy, and I hope today is the most gorgeous day in history for you. This is a little killer Sudoku. We have normal Sudoku rules, 1 to 9 in each row, column, and 3x3 box. Additionally, we have some clues outside the grid, and we'll use this one for example. The 15 here is pointing at this diagonal, and it's telling us that the sum of the digits in these three cells is 15. And those are the rules. So Bill has given us a couple of digits immediately, because these are one cell clues. This must be a 1, and this must be a 9. And now we're going to look at these two cells. We need to make 5. There are only two ways to do that in two cells. One of them is 1, 4, but we have a 1 in the box, so this must be 2, 3. And then to make 15 in 3 cells, without using 1, 2, or 3, the minimum we can have is 4, 5, 6, and that does sum to 15. That's going to leave 7, 8, 9 in these cells. We have a 7 here, so 7 goes there. The 8 places 8 there, 9 there. This is not 5, this is not 6, and this is not 4. The 29, still has some options. We have 15 so far, so these two cells need to sum to 14. There are a few ways to do that, so I'm going to leave that unmarked. This is 8, and this is 3. I didn't even see that those were one cell clues. Let's go down here, because this is sort of the mirror of box 1. 15 in 2 cells. There are again two ways to do it. One of them is 6, 9, but we have a 9 in the box. So the other way is 7, 8. And then without 7, 8, 9, the highest we can make this is 6, 5, 4, which again is 15. So these are 1, 2, 3. There's a 2 here and a 1 here. And here we have 3, so these are going to sum to 9. Lots of ways to do that in 2 cells, especially that don't see each other. In Little Killer, we can repeat digits as long as they're not in the same box. So either of these could be 1 or 2. Over here, we have a sum of 8, but we can't use 1, 7, and we can't use 3, 5. So this must be 2, 6. And that's not resolved yet. Let's clean up a little. This can't be 4, this can't be 5, this can't be 6. 22. There are two ways to do that. One of them is 9, 8, 5. The other one is 9, 7, 6. But we've used the 6 here. So this must be the 5, 8, 9 version. And we have a 9 and 8 in the column. And we have an 8 in this column. So that is resolved. That 5 looks over here for 4, 6, 5. Last digit in the box is 7. This 5 is also going to look here for 6, 4, 5. And the 3 here resolves 2, 3. And the 8 here resolves 7, 8. It's been there for a while. The 2 resolves 6 and 2. And so that's 3 of the corner boxes. Let's look at this one. 13 has some options. We can have 9, 4. We can have 8, 5, and we can have 7, 6. 2 of those options are ruled out by the box, so this must be 4, 9, and it has to be in this order because of this 9. The 10 here, the remaining digits are 1, 2, 3, and 5. The only way to make 10 from those is 2, 3, 5. We have 2, 3 here, we have a 2 in the row, and then 1 left to finish the box. So we still have a few clues to resolve. We'll start with the 10 here, because we already have 7 on this clue. So what we're left with is 3. The only way to do that, even 2 cells that don't see each other, is 1, 2. And there's a 1 in the top row. It's going to leave a 3, 5 in this column, and a 4, 7 is resolved here. These are 3 and 6. These are 1, 8, 9. That's not 9. That's not 1. These are 8 and 9, which are resolved. These are 4, 6, and 7. Okay, so now we have 3 digits on this clue. So this is 22. To make 29, we need another 7. So lots of repeats on this one. That 7 looks over. These are 5 and 9, and we have a 9 in the row. That 5 resolves 3 and 5. These are 2, 3, which are resolved by that 2. These are 1, 4, 6. That's also not 1, so that's our 1. Gives us a 4, 6 pair here, so these are 5 and 8. And we know the order from that 5. So that's not 8. We need a 2 in this row, and there's a 2 there. And then we need 3, 6, 7 to finish that box. Alright, down here we need 4 and 9, that's resolved. That 9 looks up to resolve 8, 1, 9. And the 17 here is resolved. Probably could have done this a lot sooner, but just doing Sudoku. So 7 and 4 is 11, plus 5 is 16. We need a 1 to make 17. These are 6 and 7. And now we have a 6, 7 pair here, resolving our 3. And the last digit here is an 8. 6 and 7 are in this row, so this must be 3, 6, 3. So 7, 6, 7, 6, 6, 4, 6, 4, 7, and a 2 to finish off. That's the solution. So I hope you enjoyed that. Bill gave a hint with this puzzle regarding triangular numbers, which are very important in a lot of the mathy variants when it comes to finding minimums or maximums. So one way we could have looked at this is we have a 1 and a 5 clue, so these 3 cells must sum to 6. And 6 is a triangular number. It's the 3rd triangular number, so this must be 1, 2, 3. Or we can add in the 15 and we get 21. 21 is the 6th triangular number, so we need the minimum in those 6 cells. So, neat stuff there. Let us know how you did in the comments, and I will see you next time.